Hey, AP Stats, let's start with some conditional probability today. What is conditional probability? It's finding out the probability of something happening given another event has already occurred, okay? You're gonna see some key word or phrases, and the biggest one is just the given, or you'll have some kind of assumption that is stated, okay? It won't always say given. Now, there is some notation that you have to understand, okay? And it can look a couple different ways. On the formula sheet, it looks like this. But in a lot of books, you see it looking like this. So I have both of them up here. How we read this notation is we say this is the probability of B. So we want to figure out the probability of B happening given A has already occurred. Or over here, we say the probability, what is the probability of A happening given B has already occurred? Now there's a formula for this, and there's really, it's, in my opinion, it's easy to memorize. If you think of this probability of B given A, what you need to do is you need to think about this line here as the fraction bar. And in the denominator, we put the probability of A. And then in the numerator, it's always both. The probability of A and B happening. So the probability of A intersecting B. So over here, the probability of A given B, again, we think of this line right here as our fraction bar. So the probability of B would go in the denominator. And in the numerator is always both of them happening. The probability of A intersecting B. Okay. Now, this formula is how we figure out the probability of B happening given A has already occurred, or we figure out the probability of A happening given B has already occurred. It actually is even a little bit easier, I think, when we're dealing with what we call a two-way table. So we have a two-way table here. We've looked at this two-way table before: high school graduate, not a high school graduate, homeowner, not a homeowner. We have our totals. I always make sure you have your row totals and your column totals included in there. And if you don't, make sure you write them in, okay? So let's start with number one. If we know that a person owns a home, what is the probability that the person is a high school graduate? Okay, so on number one, how am I gonna write this for notation? Well, the first thing is always we're trying to figure out what the probability, like in this case, of B is. What is the probability of B given A has happened? Or what is the probability of A given B has happened? So the question is always what we write first, what we're trying to figure out. So we're trying to figure out what is the probability that a person is in high school, or is a high school graduate, I'm sorry. So I'll put high school. Again, I'm writing with my trusty mouse here, so given, now what is the assumption that has already happened? We know that they own a home. So you can imagine we have 500 people in a room. We take everyone's names, or we take the names of everyone who already owns a home. We put their names in a hat. We shake that hat. Out of all the people who own a home, what's the probability the person is in high school? That's what we're getting at here. Okay, so we're going to put owns a home. Now for a two-way table, we use this same formula, kind of. We're not gonna figure out the probability of A or the probability of both. We're gonna just look at the two-way table and make it even easier for ourselves. Well, instead of figuring out what's the probability they own a home, we're just gonna look and say, well, how many homeowners do we have? That's gonna go in our denominator. We're only dealing with homeowners here. I like to have people in a two-way table circle the given, because then we know, hey, we're trying to figure out out of everyone who owns a home, 340 people, what's the probability they're a high school graduate? That's right here, 221. Okay, denominator, boom, both a high school graduate and owns a home, boom, 221 out of 340. And you can leave it just like that, that's fine. Or you could change it to a decimal. Doesn't matter. Let's look at number 2. If we know that a person is a high school graduate, what is the probability the person owns a home? Okay, so now the question is asking, what's the probability they own a home? So that's what goes first. Given now the assumption that has already happened, we know they're a high school graduate. You can imagine we have 500 people in the room. We take all of our high school graduates. We put their names in a hat. How many high school graduates do we have? We have 310. Sorry, I went over it a little bit. In the numerator now, we need people who own a home and are high school graduates. That is right here, 221 out of 310. All right, what should we have learned from this? With a two-way table, circle your given so you know these are the numbers. You're going to be working with only these numbers, right? What else should we know? Hey, in the denominator, we think of this as like our fraction bar. We put whatever's to the right of it in the denominator and both in the numerator on that two-way table. Let's look at it a different way. Let's look at it here we have in an apartment complex, 40% of residents read the USA Today, 25% read the New York Times, and 5% of residents read both papers. What's the probability that a randomly selected resident who reads the USA Today also reads the New York Times? Okay, let's read this slower. What's the probability that a randomly selected resident who reads the USA Today? This is the given right there. We know they have to read the USA Today, a given assumption. We want to figure out what's the probability that they also read the New York Times. This is the question. So what's the probability they read the New York Times given they've read the USA Today? What do we know in the question? Out of everyone who reads the USA Today, well, what is that? 40% of them read the USA Today, okay? So 0.40. I could have put 42. Whenever I'm dealing with mathematics and I have a percentage, I just naturally always move that decimal 2 to the left, okay? All right, so again, we're using this formula here. The denominator is whatever's to the right of the line. To the right of the line is the USA Today. Everyone who reads the USA Today, 40% of them. The numerator then is both the New York Times and the USA Today, and that's 5. Okay, we can put that in our trusty calculator. And we get 0.125. What do we do? We just reminded you, okay? Line, here's my given assumption, that goes in the denominator. Both goes in the numerator, and there's your conditional probability for you. Okay, we're done with the first part of the video. Next video is going to be about independence. Thanks, guys.